Now we shall solve one simple example on single phase AC circuit. Of course, as I have done earlier, I have taken an example from the textbook, which is a solved example. Let us see how to solve it. It's a simple example. It is based on series uh, RC circuit. You can see the problem statement. A capacitor of 79.5 microfarad is connected in series with the non-inductive resistance of 30 ohm. So this is 30 ohm. It is not clear here, but it is 30 ohm across a 100 volt 50 hertz supply. So what you are supposed to find out is the impedance Z, the current I, and the power factor cos theta. These are the three things which you are supposed to find out here, right? So now let us look into the circuit first. Okay, I have drawn the circuit here. You can see here you have got a capacitor which is of 79.5 microfarad. You have got a resistance which is 30 ohm. Both are in series, which is connected across 100 volt 50 hertz supply. Now you are supposed to find out the impedance, you are supposed to find out the current, and you are also supposed to find out the power factor. So in this particular example, if at all you want to find out the value of the impedance, you know that first the capacitive reactance is to be found out. Capacitance is different and capacitive reactance is different. This is a very important point to be noted. In some examples, you may be given the value of capacitive reactance directly. That will be always specified in ohm. If the capacitive reactance is given directly, then you need not calculate the value of Xc. However, if you are given the value of the capacitance, then you need to calculate the value of capacitive reactance. So this is a very important point to be noted here. So now you have also seen earlier that capacitive reactance is given by Xc is equals to 1 divided by 2 pi Fc, as I have already written here. So now in this problem, the value of capacitance is known to us, that is 79.5 microfarad, which is also 79.5 into 10 to the power of minus 6. This also you are supposed to remember, 79.5 10 to the power of minus 6 farad. F is given to be 50 hertz, as you can see here. Then you have to substitute the value of Xc, which is equals to 1 divided by 2 pi Fc. So now if you substitute the value of Xc, you will I will just write it here once again. Okay, so Xc is equals to 1 divided by 2 pi. F is 50, C is 79.5 into 10 to the power of minus 6. So this will give you the value of Xc as some ohm, right? So let us see how they have calculated. So the same way it is calculated here, and you are going to get the value of Xc is equals to 40 ohm. You can see here Xc is equals to 40 ohm by keeping the same substitution, right? So once you have calculated the value of Xc, you know that Z is equals to R minus JXc. So when Z is equals to R minus JXc, here it is written as R plus JXc, which is not correct. Please remember, this is not correct because XC is always minus JXc. XL is always plus JXL. I don't know in what way they have taken. That is the reason why deliberately I have taken this example. So your Z here should be always R minus JXC. Z is equals to R minus JXC. So R is given to be 30 ohm minus J 40 ohm. If you calculate, right, you just find out how much you are going to get here. If it is, it should be minus 40 here, this should be minus 40. So 50 at an angle 53.13, the answer may be right. Please use your calculator and calculate the value of Z. Only thing is that this substitution, that is plus x, is not correct. X is always minus. So 50 at an angle 53.13 may be correct. Otherwise, you may get 53.13 with a minus sign. Okay. So now 53.13 with a minus sign is correct because your power factor in a capacitive circuit is always leading in nature. Now you can see here, once if you calculate the value of Xc, okay, so I will come to the next. This is 50, what was that value, let me see it. Yeah, this is 50 at an angle 53.13, 50 at an angle minus 53.13 ohm. This is the value of Z. Okay, please check this answer. Then your V is given by 100 volt at an angle 0. So you have 100 at an angle 0 degree, 100 at an angle 0 degree. So you have I is equals to V divided by Z here. So if you take I is equals to V divided by Z, you will get I is equals to 100 at an angle 0 divided by 50 at an angle minus 53.13, if I am right. So this is going to give you 2 at an angle 53.13. So now once this 53.13 with a negative sign is in the denominator, if you take to the numerator, you will get it as 53.13. That means the current here is 2 at an angle 53.13. Now this should be right because my V is somewhere here. We have already seen the phasor diagram. The current with respect to this will always have an angle something like this. This is 53 point, one second, 53.13, this angle 53.13, and this is the current vector. So this is how you should get the value of the current, and here whatever is done in this problem is not correct. Please do not follow such problems, do not follow such books, because your I is V by Z. Z here in this case must be having a minus sign because it is a capacitive reactance. Okay, so the current magnitude is correct, but the angle is 53.13 plus. If it is minus, it is understood that with respect to voltage the current is lagging, right? We cannot have a lagging power factor in a series you know RC circuit. In a series RC circuit, as per our conventions, the power factor is always leading, right? Leading means it should always follow the, I mean it should also, it should be always ahead of the voltage vector. So this is one thing which you should know. This is one such problem. I will solve one more problem after this, right? Please try to understand this. So this you change to minus 53.13, and accordingly you will get plus 53.13, and your cos theta is nothing but cosine of the angle 53.13. Whether it is plus or minus, that doesn't make any difference. You get the value of cos theta is equals to 0.6, but because it is RC circuit, you must write it as a leading power factor. Okay, So we will stop here. Let me come with one more example later.